we are solving electrostatics questions of previous year CBSE Standard 12. Okay, so these questions are asked in year 2024. Okay, let us solve one by one. First question. Now, two charges plus Q are kept to a distance apart. So this is plus Q, suppose, and this is plus Q. So the distance of separation between the two charges is 2a. A third charge minus 2q is placed midway. So at the center, minus 2q charge is kept. Okay. The potential energy of the system. So what is potential and what is potential energy? Potential is 1 by 4 pi epsilon 0 into charge divided by the distance. Okay, this is distance, this is potential, and potential energy is this into the charge. Okay, this is called potential energy expression. So let us see. The potential energy on plus Q charge, because of this plus Q charge is P1, suppose 1 by 4 pi epsilon 0. Okay. Now, potential energy on on minus 2q charge between these two systems, minus 2q and plus q is plus q by a is the distance, okay, and minus 2q is the charge here. Okay, so potential into charge is equal to potential energy here. Okay, now similarly potential energy 2, because of this plus q charge, what is the potential energy? Plus q by a into the charge minus 2q, correct? Similarly, potential energy of these two system plus q charges is q by 2a. 2a is the distance and charge q. Okay, so the three potential energies are scalar quantity. We have added these three potential energies. Okay, separation of plus q and minus 2q is a. Plus q and minus 2q is a, and separation between plus q is 2a. Okay, so now if we add up these three potential energies, then the total potential energy of the system is how much? Minus 7q square by 8 pi epsilon 0 a. So this tallies with this. Okay. Second question. Now, two identical small conducting balls B1 and B2 are given minus 7 picofarad and plus picocoulomb and plus 4 picocoulomb charges. Okay, so B1, B2, this is B1, this is B2, this is minus 7 picocoulomb and plus 4 picocoulomb charges are given, okay, respectively. They brought in contact, okay, with a third identical ball. Identical means size of this ball B3 is same. So B3 is same, okay, and then separated. And this, okay, so B1, B2 and B3 are kept in contact and then separated. Now, after separation, each of this ball, B1, B2, B3, they all are now having a charge minus 2 picocoulomb, okay. So we have to find out what was the initial charge in B3. So what is the principle? We will apply the principle of conservation of charge. So initial, before connecting them, okay, what was the initial charge of this system? Suppose in B3 ball, the initial charge in B3, suppose, let us say in B3, initial charge is Q. So the charge in B1 is minus 7 picocoulomb, charge in B2 is 4 picocoulomb, and charge in B3 is plus Q. That plus Q we have to find out. So after connecting them together, each ball is having a charge minus 2 picocoulomb. Okay, so there are three balls, the minus 2 picocoulomb into 3. So initial charge equal to final charge of the system. So in this way, Q is the only unknown, so we can find out Q is equal to minus 3 picocoulomb, correct? So this is second question. Now this is also 2024 question. So electrostatics is important chapter in your coming board exam. Here electric field of the region is given by E equal to 10x plus 4I. What kind of field it is? It is distance dependent field, and the direction of the field is along x-axis, because I is a unit vector along x-axis, correct? So now x is in meter, and electric intensity is force per charge, so it is Newton per coulomb. Calculate the amount of work done in taking a unit charge from 5-0 to 10-0. Okay, means along the x-axis, suppose this point is 5-0, and here you have to shift the charge from say A to B, and here the coordinate of this, abscissa of this is 10, 0. Correct. So we have to find out what is the work done. And second part of the question says that you have to shift it from 5-0 to 5-10, means along y-axis, correct? Along y-axis you have to shift. Let us do one by one. So we know that work done is equal to charge into potential, correct? So here it is given that you have to shift a unit charge. The given charge is unit, so 1 coulomb. So let us make it 1. So the work done is equal to the potential difference. Okay. Now what is relation between potential and intensity? We know that intensity is potential gradient, means potential by distance, and negative sign indicates the potential decreases in the direction of intensity, correct? So this is the relation. So what is dV? dV is equal to dV, potential difference, is equal to minus E dx, correct? So E is given, so E dx. So total work done is equal to, we have to integrate this E dx. Let us put the value of E here. E is equal to how much? E is 10x plus 4. This is the value of E. And from what to what? The only x is changing in the direction of x, in the direction of I we are moving, correct? So it is the lower limit of this integration is 5 to 10. So 5 to 10 we have to shift it, correct? So we have to integrate 10x plus 4. Now we know that integration of x to the power n is equal to x to the power n plus 1 by n plus 1, correct? So what is integration of x? It is x square by integration of x dx is x square by 2. What is the integration of 4 dx? 4 is constant dx. So there is nothing, means x to the power 0 is there. So it is 4 into x to the power 0 plus 1 by 0 plus 1, 4x. So integration of 4 dx is 4x, and integration of 10x is, 10 is constant, integration of x is x square by 2. Now put the lower limit 5 and upper limit. First the upper limit we put in place of x, then the lower limit. So it is coming around minus 395 joule. So this is the work done. Now second part of the question, here 5-0 to 5-10 we have to shift. Okay. So let us imagine this is the direction of intensity, which is along the direction of x, and we are moving in y-axis. Okay, so this force, this intensity has no impact here. What is the component of intensity? What is the component of force along y-axis? It is E cos 90. Cos 90 is 0, means 0. So no force will act on y-axis if we shift the charge along y-axis. This is 5-0 to 5-10 is clearly y-axis movement, correct? Here you see that x is not changing, x is 5 constant. Only y is changing from 0 to 10, from 0 to 10, correct? So there is no force on this, so therefore there will be no work done. Okay, or you can do one thing, you can use the same expression, work is equal to minus E dx, and the limit of integration you can put 5 to 5. So the upper limit, lower limit both are same, therefore the resulting expression work done is equal to 0, correct? So either way we can show in this format, and keep the limit same and say that it is 0, or we can directly say because the movement is along y-axis which is 90 degree to unit vector I, therefore no work is required to move along y-axis. Correct? Now next question. Now this is actually a theoretical question, but given in the form of numerical, let us see. Now dielectric slab of dielectric constant K. Okay, the dielectric constant is K. Now and thickness is T. Correct. Is inserted between the parallel plate capacitor. Okay, and distance of separation is D. So there are two plates, A and B. In capacitor, one plate is charged, A plate is charged, B plate is earthed. Okay, and the distance of separation between them is D. Okay, now a dielectric slab K of thickness T is introduced. So this is the dielectric slab having thickness T. T is the thickness of this slab is introduced. So when dielectric slab is introduced, the air thickness reduces. Earlier air thickness was D, but because of T thickness dielectric, the air thickness is D minus T. Correct? Now, so there are two electric field. One is in air, other is inside dielectric. So if we want to move, if we have to find out the expression of capacitance, then we have to find out the first potential, and Q is equal to C into V. So capacitance is equal to Q by V. So first of all, let us find what is V, the potential. Okay, potential difference, the amount of work done to move it from plate A to plate B. Okay, so this movement is taking place along air as well as inside the dielectric. Okay, so suppose Q is the charge on this plate A, minus Q, automatically this is the bind charge in B. Correct? Sigma is the surface density of charge. What is surface density? Charge per unit area. Suppose A is the total area of this plate. Correct? This is the parallel plate capacitor. So A is the area of the plate. So therefore, if A is the area of the plate, then the surface charge density is charge per area, Q by A. Now D minus T is the air thickness, effective air thickness after introduction of this slab. A is area. So what is intensity? We know that from application of Gauss's theorem, we know that intensity, in air because of a charge plate is sigma by epsilon 0. And what is sigma? Sigma is charge density, charge per area. So intensity in air, the electric field in air is equal to Q by epsilon 0 into A. Similarly, intensity inside dielectric is equal to how much? Sigma by dielectric constant, this is given as K epsilon 0, correct? So what is R? Dielectric constant relative permittivity. It is absolute permittivity by permittivity of air. This is K. K is given. So permittivity, absolute permittivity is K times epsilon 0, correct? So intensity inside dielectric is sigma by epsilon. Epsilon is permittivity of the dielectric. So absolute permittivity is written as dielectric constant into permittivity of air, correct? Now, so if we put the value of sigma as Q by A, then it is Q by K epsilon 0 A, correct? Now, what is total work done? Work is equal to intensity into distance. So in air we have to move it by distance d minus t, and in dielectric we have to move this charge by a distance equal to the thickness of this slab, E2 into t. So potential difference between A and B is equal to, put the value of E1 and E2 here. Okay, now let's calculate it. Q is common, and it is d minus t plus t by k. This is what? This is the total potential difference between the plate A and B. So therefore capacitance, as we know, capacitance is equal to capacitance of a capacitor is charge by potential difference. So it is charge Q by potential difference between AB, Q by, we already find out this, so Q cancel out, so epsilon 0 A by D minus T plus T by K. So introduction of a dielectric slab of thickness T changes the dielectric capacitance by this. Without this thickness, what was the capacitance? It is epsilon 0 A by D, correct? So when entire area between the plate of the capacitor is air, then this is the capacitance, okay? When suppose it is C0, and when T thickness slab is introduced, then this is the thickness. So very good, very important expression for you. Now next question. Two capacitors of different capacitances are connected, okay, in series, connected in series and then in parallel, okay, with a DC source 100 volt. Okay. Now if the total energy stored in the combination in the two cases is 40 millijoule and 250 millijoule respectively, find the capacitances of the capacitor. Okay. So two capacitors are connected in series. Suppose this capacitor is C1, this is C2. So when they are connected in series, then what is the equivalent capacitance? C1 C2 by C1 plus C2. This is the equivalent capacitance in series. Okay. Now when the two capacitors are connected in parallel with a voltage source of 100 volt. So then what is equivalent capacitance in parallel? If C1, C2 is individual capacitance, then equivalent capacitance is in parallel equal to C1 plus C2. Okay. So when in series, then what is energy stored? Energy stored is equal to half CV square, half C into V square. So we put the C means in series what is the equivalent capacitance, and then when parallel we put this, correct? So this is the initial energy when they are connected in series, 40 millijoule. This is the energy of this combination when they are connected in parallel. Okay. So in parallel, the equivalent capacitance C equivalent in series is equal to C1 C2 by C1 plus C2. So what is energy? Half C capacitance, equivalent capacitance into V square, correct? And when in parallel, then also energy is half CV square. So capacitance is C1 plus C2. Voltage is 100 volt. It is given 100 volt. So let us put the E1 and E2 value. Now it is simply a arithmetic calculation. So first of all we find the C1 plus C2 from this. Okay. Then from this expression, if we put the value of C1 plus C2, then we find C1, C2. Now there are two variables, C1 and C2, and two equations. So how to find out? We know that C1 minus C2 whole square equal to C1 plus C2 whole square minus 4C1 C2, correct? So if we calculate these two and then add C1 plus C2 and C1 minus C2. C2 cancel out, only C1 remains. Similarly, we subtract, then we get C2 value. So thus in this way we find that the capacitance of the first capacitor is 0.4 into 10 to the power minus 4 farad, and then the second capacitance is 0.1 into 10 to the power minus 4 farad. Okay. So we'll continue our discussion.